Hello, my name's Manjot Singh. I'm lead enterprise architect at MariaDB, and we're going to be speaking about how the queries move through the MariaDB engine. So let's talk about users. You may have an application user, and you may have an application end user, and you may have a DBA. And you may also have your cron jobs, let's say. And what these guys are going to do is connect with various users. So this might use the connector. And the DBA may use the MySQL command line. The cron job, maybe it's using MySQL admin. And what they do is connect to the MySQL D daemon. So the MySQL D daemon looks for data. And how does it do that? It does that with the application, the handler interface. And the handler interface connects to storage engines. Storage engines. And if you don't know about storage engines, they basically allow you to do many different workloads within the same database with the same SQL. And that's the value of these different types of storage engines. So the handler interface kind of sits right here, but let's talk about the internals of your storage engine before we do that. Let's dig a little deeper. So the query comes from here, goes through MySQL D, sort of a black box here, to the storage engine. So what's inside of MySQL D? What we have first is your query actually goes to the thread cache. The thread cache basically stores your threads as you connect, caches them, and allows and keeps track of those. So normally a single query for a single thread, single CPU thread, right? And with thread pool actually, which could replace this thread cache, you can have better than caching. You can reuse threads within that pool with varying connections instead of one connection per thread. But let's talk about one connection per thread. Right? So these guys connect through MySQL D to the thread cache. From the thread cache, the query goes to the query cache. Now, this is if you have query cache on. I highly recommend disabling query cache for most workloads. And the reasoning is this is not multi-threaded. The query cache feature is actually single-threaded. It compares queries exactly as they are with comments, spaces, everything. And if they don't match, it will ignore it. But it still has to go through that to find that match. So what I would do is disable that with query cache type and query cache limit off. But if you have a good use case for it, keep it on. So from there, what happens is the query goes to the first level of the parser. And what the parser does is it creates this little parse tree. It tokenizes your query, validates the SQL, makes sure that the semantics and whatever makes sense. What we'll do is, before I talk a bit more about that, we'll talk about the second part of the parser. And the second part validates our objects, our table names, our grants. And so the first part, basically, it takes the query. So let's say you do select X, Y, and Z from table 1. It takes that and it tokenizes it. It says, OK, this is a read-only query. This is looking for columns X, column Y, column Z, and table 1. Once it's done that, it says, OK, this is what we have. This is our game plan. Let's go to validate. Do these objects exist? And these objects here, we're going to say, OK, does table 1 exist? Oh, yes, it does. OK, does column X exist? Does column Y exist? Does column Z exist? And then next, what user is trying to access these? Does this user have permission to access column X, Y, and Z on table 1? So that's what that second part does. Now from there, the query moves to the optimizer. And this is where a lot of people get hung up. And the optimizer is very complicated. I'm not going to go too much into detail. Optimizer. But basically, that parse tree goes to the optimizer. And the optimizer is a cost-based optimizer. What it'll do mainly is determine your join order. It will evaluate your algebraic equivalencies. It will optimize your count, your min, your max. It'll do some subquery optimizations, and some of the modern versions of MariaDB can do some pushing out of the subqueries, evaluate them first in other threads, and bring them back. And then it outputs your query execution plan. So just a little game plan, you know, like where do we go? What do we do? So this plan is a data structure just like these are. But now that it's basically been optimized, and there's much more that the optimizer does, there's many variables that will control this. From the optimizer, we go to the handler. So the handler is really just the query execution engine. And what this does is it follows the plan that the optimizer gave it. It says, OK, now I need to do this, then I need to do that, then I need to do that. So let's look at the simple case of XYZ in table 1. So let's say this is an InnoDB table. We have an InnoDB storage engine, InnoDB. What the handler will do is say, hey, InnoDB, give me columns X, Y, Z from this table. InnoDB will say, here's row 1, here's row 2, here's row 3. And it's actually just a fire hose. And it will continue going. Then what the handler will do is it will hand this back. If you're using the query cache, it will create a copy there of each row of the response, and it will hand it back to the thread, and then the thread hands it back to the happy user. And that's pretty much how queries move through MariaDB. One of the other things that you may notice is I was speaking more about reads. When there's a write query, it's pretty much the exact same plan. It has to parse it. It has to validate the objects and the syntax. And then it does have to figure out, how do we insert these rows to the storage engine? So it will follow the exact same game plan, but instead of returning rows, it will return a result. You know, is it good or bad? Did it work? And then the storage engine handles where, how it is stored, and even when it is stored. And that's pretty much how MariaDB works. And there's a few other storage engines that I'll add in here. So there's Aria, and then there's Column Store, which is our massive parallel analytics engine. Aria is great for reads. And then there's MyRocks. And MyRocks is a highly write-optimized engine that I would look into as well. So that's how it works, and thank you for your time.